In triangle TWO, segment WT is 4 units long, segment TO is 6 units long, segment WO is 8 units long. Let's try to compare the sum of the lengths of any of the two sides of this triangle to the length of the third side. Let's take first the lengths of segment WT and segment TO. So if we add 4 units and 6 units, their sum is 10 units, and that is greater than 8 units. Therefore, our first inequality is correct. The second one is, let's take the sum of 4 units and 8 units, and that is 12 units, which is greater than 6 units, and our inequality is also correct. Our last inequality would be the sum of 6 and 8 units, and that is 14, which is greater than 4 units. Therefore, once again, our last inequality is correct. And that is what our triangle inequality theorem would want us to tell, that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So as you can see, all the sum of the lengths of any two sides is always greater than the length of the third side. We now use the triangle inequality theorem in determining whether the given lengths could be possible to be the sides of a triangle or not. The first set is 5, 4, and 1. All we need to do is to add the lengths of the two sides of the triangle, and our sum must be greater than the third side. If our sum is not greater than the third side, the said lengths could not form a triangle. So let's take first the sum of 5 and 4. 5 plus 4 is 9, and 9 is greater than 1. That's correct. The second one is to take the sum of 5 and 1. 5 plus 1 is 6. 6 is always greater than 4. Therefore, that's also correct. Lastly, we take the sum of 4 and 1. 4 plus 1 is 5. Is 5 greater than 5? It is not greater than 5. So 5 is not greater than 5, but 5 is equal to 5. But still, 5 is not greater than 5. Therefore, the condition or the triangle inequality theorem was not satisfied. Since one of the conditions was not satisfied, therefore, we cannot say that 5, 4, and 1 cannot be the sides of a triangle or cannot form a triangle. Let's now have the second set, which is 3, 4, and 5. Let's take first the sum of the first two numbers, 3 and 4. Their sum is 7, and 7 is always greater than 5. That's correct. The next one is to take the sum of 3 and 5. Their sum is 8, and that is greater than 4. That is also correct. The third one is to take the sum of 4 and 5 and compare it to the third side, which is 3. 4 plus 5 is 9. 9 is greater than 3. Since all the conditions were satisfied, this only means that 3, 4, and 5 units could be possible to be the sides of a triangle. In other words, we can form a triangle with the lengths 3, 4, and 5. And the kind of this triangle, according to the lengths of its sides, is an iscalene, or it's a scalene triangle. We now have the third set. We have 7, 9, 1. 7 plus 9 is 16, and 16 is always greater than 1. 9 plus 1 is 10, and 10 is always greater than 7. How about 7 plus 1? Is it greater than 9? 8 is not greater than 9, but less than 9. It should be 8 less than 9. Since 8 is not greater than 9, our triangle inequality theorem was not satisfied. Since one of the conditions was not satisfied, therefore 7, 9, 1 could not form a triangle. We now have the fourth set of lengths. We have 16, 40, 25. The sum of 16 and 40 is 56, which is always greater than 25. The sum of 16 and 25 is 41, and that is greater than 40. The sum of 40 and 25 is 65, and that is always greater than 16. Since it satisfies the triangle inequality theorem, therefore, we can say that 16, 40, and 25 can form a triangle. The fifth set is 12, 8, 12. 12 plus 8 is 20. 20 is greater than 12. Therefore, that condition is satisfied. The second one is to add 12 and 12 and we compare it to 8. 12 plus 12 is 24. 24 is greater than 8. And that is also correct. If we try to add 8 and 12, our answer is also 20. And since 12 is again the third side, the answer here is just the same with 8 plus 12 is greater than 12. That's it. That is 20 is greater than 12. Therefore, 12, 8, 12 could be possible to be the lengths of the sides of a triangle. And the triangle formed here is an isosceles triangle since the lengths of the two sides are congruent. The last set is 3, 3, and 3. So all we need to do is to add the two threes and compare it to the third 3. We have 3 plus 3 is greater than 3. Of course, that is 6 is greater than 3. So I don't need anymore to do another because I will just get the same answer, which is 6 is greater than 3. Therefore, we can say that 3, 3, 3 could form a triangle, and the triangle formed is actually an equilateral triangle, a triangle with 3 equal sides. Let's now try to find the permissible range of the length of the third side of the triangle given the lengths of the two sides where x is the third side. When we talk about permissible range, this is actually the allowable range, the allowed range or the permitted range of the length of the third side. So we have first the example 9 units and 12 units. So we are asked to find for the possible length or the possible range of the length of the third side, wherein we have represented the third side as x. So we have x would be one of the sides plus one of the sides 9 is greater than 12. So all we need to do is to do transposition. We transfer 9 to the right, it becomes negative 9. So we have x is greater than 3. The second one is to have this x plus 12 is greater than 9. So x plus 12 is greater than 9. We transfer 12 to the right, it becomes negative 12. Then 9 minus 12 is negative 3. So x must be greater than negative 3. However, since there is no negative length, we do not anymore consider this negative 3. We just need to consider this positive 3. The last one is to compare now the sum of the two given lengths to the third side. We have 9 plus 12 is 21. Your 21 must be greater than x. So if we try now to look at the range, our final answer must be written in this way. We have your x is the third side. Your x here must be greater than 3. Your x must be greater than 3. And your x must be less than 21 units. This is read as x is less than 21. So our final answer would be x must be greater than 3 units. This is based here. And your x must be less than 21 units. And this x is less than 21 units is based here. We now have the shortcut in finding for a permissible range of the length of the third side of a triangle given the lengths of the two sides. We let x be the third side and this must be greater than the absolute value of the difference of the lengths of the two sides, but less than the sum of the lengths of the two sides. If we try to review our answer a while back, we have x must be greater than 3 units but less than 21 units. The given lengths a while back were 12 units and 9 units. The absolute value of the difference of 12 and 9 is actually 3 units, and here it is. It must be greater than 3 units. And the sum of 9 and 12 is 21 units, and here it is, 21 units. Your x must be greater than 3 units but less than 21 units. This only means that the third side must just be between, the length of the third side must be between 3 and 21, but 21 must not be included, and also 3. 3 and 21 must not be included, but the only included are the numbers in between 3 and 21. We now have the last example, which is 8 units and 8 units. All we need to do is to apply here the triangle inequality theorem, or simply we need to apply the shortcut, which is on getting the absolute value of the difference and by simply adding the two given lengths. We now have x must be greater than the difference of 8 and 8, which is 0. X must be greater than 0. On the other hand, we need to add, we have x plus 8 rather, must be greater than x. 8 plus 8 is 16. Your x then must be less than 16. In other words, if we try to write this, or if we try to write our permissible range of the length of the third side, our third side, x, must be greater than 0 but less than 16 units. In other words, the length of the third side must be between 0 and 0 to 16. It must be between 0 to 16. 0 is not included and 16 is not also included.